Hello everyone, happy Monday evening, and we've got a great lineup lined up for you tonight. And you're not going to be hearing from me, you're going to be hearing from two awesome speakers. And I'm going to introduce them as they come on, but Bianca is going to be talking about basically machine learning and stuff that goes way over my head, but I'm really excited to see this talk, as I'm sure you are as well. Thank you so much for GDG Cloud. That's GDG Cloud, get it right second time, for organising this event, and for the two awesome speakers taking their time to share their knowledge and their experience with us. If you do have any questions, just write it in the chat and I'll try and collate them. So when it's Q&A at the end, then we can go through them. So don't be shy, just put it in the chat. And anything I can answer during the conversation, I will just write it in the chat. And then after Bianca, we have Will, who's going to be talking about, I've kind of paraphrased this, it's resilient decoupling applications. My understanding is it's microservice front end, and he's going to use Angular as an example, but it's not just with Angular. And Amanda has asked a really good question, and I have a button here that should bring it in. So what's coming up next in my channel? So I have every day a brown bag, lunch and learn, chill session, 1 till 2 UK time. And I'd love for you all to come and join, share your challenges, your successes, and every day we can just keep helping each other and making sure that we do something little and often. So that's the plan. Bring your food and we'll just chat and chill. And I do have people planned to join the lunchtime streams to give a lightning talk, kind of 10 to 15, 20 minutes, and then you can ask them questions. I do have about 15 people lined up, and in the next few days, next week, I'll start ramping those up. So some days it's just me, and you have to get stuck with me, so sorry. But other days it will be other people, and I will share those in advance. So Bianca's here and she's ready, so we're going to say hello together and then I'm going to leave her to it. Today is a bit of an experiment because I have to control the slides, so if anything goes wrong with that, that's my fault. So let's bring Bianca in. Bianca, how are you?
Hi, I'm fine, Eddie. How are you?
I'm good. Como estás? Tudo bem? How's my Portuguese? Is it okay?
Yeah, it is. I actually understood you. Estou bem.
Thank you.
Obrigada.
You sound surprised. My Portuguese
Yeah,
is
it
very
was.
bad. It's
No, it's just
awesome to have
surprising.
you here. So the plan, I was just saying to the audience, the plan is we're going to just do a bit of an introduction to yourselves now, and then I'm going to leave you to it. And I will still be here, so if you need anything, just shout, I'll be here. And unfortunately, I have to control your slides. So you have to kind of give me that nod and wink when you're ready to go to the next slide.
Okay, we'll try. See how
We'll
it
try.
works.
This is an experiment. It's the first time I'm doing
Yeah.
it with someone who has slides. So
Okay.
yes, it's going to be interesting. Eddie's Portuguese has definitely improved. Thank you very much, Amanda. I'm going to put that on the screen. I'm really proud of that. And I just want to say one last thing in Portuguese to Bianca. Muito prazer. Is that
É
correct?
muito prazer. Yes, that's precisely right.
Awesome. So why don't you introduce yourself, tell us about yourself, tell us where you're calling from, and yeah, tell us the background.
Okay, so I'm calling from Recife in Brazil. Is one of the capitals by the beach. Not right now. Right now we're all locked in, but I work for a company as a product manager on AI, and I'm a GDE, a Google Developer Expert on machine learning. Um, I don't know. What else do you need me to talk about?
No, that sounds good. You're from Brazil. You said the tech that you use. I'm really excited about your talk. So let's just go into it. So I will leave you to it. So I'm going to disappear, but I will be here, and I will be able to hear you. So let's go, and let me make your slides full screen before I forget.
Okay.
And let's hopefully this all works to plan. Well, I'll see you in a bit, and I'll leave you in Bianca's capable hands.
Let's hope my hands are capable, right? So I'm here today to talk about modeling and viewing explainability. And I'd like to start with one question, which is, can we lay back and chill after training a model if its accuracy on the testing data is high? Because usually we tend to check some indicators, but the most important one tends to be accuracy. So if our model is, I don't know, let's say if we have a model that is like 90%, all right, so we should be fine with that, right? And go ahead and that's weird. There's another one missing. There's a lot of slides missing. Sorry, guys. Okay, well, essentially, there's something missing still, but no, we cannot chill. There's a lot of work we have to do in actuality, and we need to check for a lot of other things because usually we have to fine tune the model. Don't worry about it. Don't worry about it. We have to fine tune the model. So I'm going to tell you a story, which is a benchmark that is very common and popular in machine learning. And this is the story of a classificator, a machine learning model, right? That it analyzed images and it could tell whether it was a wolf or a husky on the image. And this model, it was made, I think, by the University of California, Irvine. It was a really serious model, really serious institution. Go ahead, Ed. And it was very impressive because this model was 100% accurate. It was like, wow, doesn't matter what you put in, whatever comes out is 100% accurate. So everybody was like, wow, this is never heard of. This is amazing. This is incredible. And the model was open for people to tinker with it and play around a little. And here's what they found. So you had wolves, and you had huskies. And usually the prediction was always right. So you had like the prediction was wolf, the truth was wolf, and husky. But in the end, problems started happening because the algorithm predicted wolf and actually was a husky. So keep going, Ed. Yeah. So whatever was wrong here, right? Like why all of a sudden the model started going wrong? Had it unlearned what it had learned before? But no, the problem was that. Keep going. So essentially what was happening was the model was predicting whether there was snow in the image. Usually wolf pictures had a lot of snow and huskies tended to be in other environments. Usually they were like on more grassy, more green, like greener environments. But in the end, that last picture, the husky was on snow. So the prediction was wrong because it wasn't actually predicting what the developers thought it was predicting whether there was snow or not. And this is something that we have to take to heart because if I have a problem that is 100%, it's possible for me to get 100% accuracy on the model. It's probably it isn't a machine learning problem because machine learning is probabilistic. So I'm never going to get it 100% of anything. So there is other ways I can solve for that problem. Like is there snow in the picture, which can be not very smart ways, but there are ways I can do it with traditional programming. So yeah, if they had bothered with explaining like the issues before, that wouldn't have happened. You know, they would have noticed that it actually wasn't a classificator for wolves or huskies, but for snow or no snow. Keep going. Yeah, so no, we cannot chill, right? Because we have all those problems that we might not understand. They're there unless we try to explain our models. So next. From the point of view of the programmer, like of the data scientist, of the data engineer, or whoever is building the model of AI, we often have to fix and tune the results. And I brought you one example of that. I have another example from the company I work with, Guppy. We are a HR tech company, and we help people hire better. And we've constantly had problems with internship vacancies, internship spots, because often the algorithm would suggest people that they were no longer in college. And in Brazil, it is mandatory for you to be in college in order to have an internship. So we started to we had to explain why that was happening, why our model was consistently giving imperfect suggestions. And we realized that a lot of companies open jobs for interns, but in the end, they ended up hiring people who were not interns, who were not in college, but still they subscribed and they tried that specific job spot, the job vacancy, which is very common in Brazil. People will do that. People will try to get jobs they're not actually they're not really right for. And sometimes it works. So in the end, the algorithm learned poorly, So we had to fix and tune the results in order to give better suggestions for interns. And now this is fixed. But yeah, we had to go there. So is it good what about regulators? Is it important for us to have explainability for regulators? And yeah, it is so important. Keep going. Because regulators need to check for conformity. We have now systems that are making very important decisions in all areas, in the medical area, in the criminal area, in financial areas. So they need to check if we're not doing it right, if we're not making decisions based on biases, if we're not being prejudicial towards certain groups of people. So I need to explain in order for people to check if my algorithm, if my model is compliant with the law and regulations of a country. Next. And what about our users, right? Is explainability important for users? And yes, it is important. And the thing is that they need to build trust in the system. A lot of people, a lot of users don't know that the Google search is an artificial intelligence algorithm, right? That ranks our searches and provides the best results. And it was easy to get that going before, but now we're in a much more informed area, and people are very wary of what's going on, and they want to understand why things are happening. So the best way to build a relationship with your user is if you help them understand what's going on, to build trust in the system. So explainability is actually important to everyone. It's important for developers, important for regulators, important for users, everyone in general. Yeah, keep going. So just for us to have a general idea of what explainability is, at least how I like to describe it, explainability is the degree of human understanding of a phenomenon. A model does not have to understand what's going on. It just attributes values and looks for patterns, right? But we want to understand the why. So, or at least what was taken in consideration for the model to get to a given idea or a given result. If you want to look for it, if you want to research on it, this also goes by the name of interpretability. It's the same thing, pretty much. There are subtle differences, but essentially is the same idea, where you have a degree of human understanding of a phenomenon. And another definition I like, which is on the next slide, is that explainability is what allows for better conversations among developers or users and regulators, everyone in an ecosystem. And this is a definition by Jez Holbrook. He's one of the founders of Google Pair, which is people and AI research. And yeah, if you want to make AI that is focused on people and on helping humans and not Skynet, you should be considering that when you're developing, right? So yeah, next slide. There are essentially two types of models you can make. There are models that are inherently explainable, they are interpretable, and there are models that are the black box models. People will say all the time the machine learning is black box inherently, which is not true, because it depends on what you're using. Neural networks are inherently black box models because there are hidden layers I cannot explain. But I can have machine learning models that are based on logistic regressions or innate Bayes and a lot of different algorithms, and they're inherently interpretable. I'm going to try to show you why, more or less. Next. Another thing that we have to take in consideration when we try to understand what is explainable is that I have local explanations that show me what's going on within a specific data point, and global explanations that say how all those data points connect and how they behave in general. So I have local and global explanations for data points for models. Next. So I'm going to show the full schema later, but the first thing I'm not going to talk about here, but it's really important, is data explanation. You have to understand your data. You have to understand if it's comprehensive. You have to understand if it doesn't carry any biases that shouldn't be there. And then if you choose to train an interpretable model, a simpler model, you can have a direct global explanation because the model is interpretable. And I'm going to see why. And then we have also direct local explanations. So next. So suppose this is a very, very common case. Is a benchmark also for whoever is starting with machine learning. And this is the Titanic, right? We can build a classificator using decision trees, and we know whether the person has survived using the information of gender, age, class, and origin, like where did the person embark from. So in general, I can explain whether a person has survived or not because they say, well, this model takes into consideration gender, age, class, and origin. And I can also see where the nodes are divided, like the division of the nodes and what type of characteristics is taken into consideration. So like the age, is it lower 18? Like is it below 18? Is the person young? Is it a like class? Is it a person from the third class or not? Like I understand how the model behaves as a whole, and I can explain what is taken into consideration. When the model is explainable like that, I can also explain specific data points. So next. So everybody remembers, right, Jack, and how he did not survive because of the plank that he could not stand on. And yeah, Dame Kate. So yeah, he's a man and he's older than 18, right? So essentially I know that he's dead. I know that he died, yeah, because the model allows me to explain this specific data point. I can connect it directly with the model. So I have a global explanation and I have a local explanation. Next. Things aren't always that simple, right? Especially when you're very interested in building more complex models. And sometimes they're really necessary. Like it's for dealing with images, for instance. Like you will use a neural network. So you end up building a black box model. And then you have to kind of provide an explanation afterwards because the model does not explain it for you. Like you cannot look inside the model. And you have to build a post hoc is after the fact. Like so after the fact, after the model runs, I have to provide a global explanation. And I tend to do that by building an interpretable model. I'm sorry, I didn't translate everything, but I think you can understand. So, and then a post hoc local explanation too, which is something you do after the model is already given results. So let's see like a more palpable example. Next slide. Essentially what you can do is you can build secondary models that try to explain the primary models. You have a very simple schema of a neural network with 3 hidden layers. And there's no way to tell how those iterations happen, right? You only know what's getting in the input layer and what's getting out in the output layer, but you don't know the iterations in the hidden layers and what the model is taking into consideration. So what you can do, and it's a common practice in the industry, you can build a secondary model based, for instance, on decision trees. And here is a simplified version of how you think the first model is behaving. It is not perfect, but is a good approximation, right? The problem with that, it's a good thing and it's a bad thing as well. Let's see the next slide. Yeah, it's kind of like that. Like the primary model is an actual bear, like it can actually bite you and kill you. The secondary model is a fluffy teddy bear, but it actually got some of the important features, right, from the first model. Like it's brown, it's furry, it has really big teeth, and it has an open mouth. So yeah, we could say that like the main things from this model are being represented in the second model. This is an example from a, sorry, can you go back real quick, Eddie? Thanks. This is an example of this is a presentation that is directly underneath. Is the black swan of perfectly interpretable models. It's a presentation that is on InfoQ by two great guys at Salesforce, Einstein. And if you can check it out, it would be great too. It's like they teach you a lot. So next. Now we're going to try to talk a little bit, it's not a lot, but just a little bit about models that explain other models. And we have two major contenders here. Like there's a lot of options, but there are two that are the most common. The first one is LIME, which is the next one. Next slide, please. Yeah, so this is its name, LIME. Next slide. Yeah, so you have LIME stands for Local Interpretable Model Agnostic Explanations. So essentially what the model does it takes the data and it tries to determine whether that type of feature, like that characteristic of the model, it's correlated and how it's correlated, if it's negative or a positive correlation. So like for instance here you have sneeze. If the person's sneezing and the person has a headache, but has no fatigue, like what could that be, right? Like it won't tell you what it is. The human will make the decision, but it will present it like, for instance, if you have sneeze and headache with there's a high correlation and possibility that it is a flu, for instance. And there is a lot of ways in which you can use LIME. It is model agnostic, so it doesn't matter what are you using, like which type of algorithm you're using. It helps you explain with a linear approximation. But here, like in the example below, it tries to show you, like I have a dog like playing a guitar, right? So in the original image, I have all the information. I have everything there. And then when I use LIME to explain, like for instance, a model can say, oh, this picture contains an electric guitar, or this picture contains an acoustic guitar or a Labrador. And LIME helps you highlight which pixels were used in order for the model to get to that conclusion. So for electric guitar, it took in consideration, like, I don't know how to say that in English, but I think it's the guitar arm, right? And for the acoustic guitar, it's like the whole body there. And for Labrador, it highlighted like a little bit of the paw below the picture and the dog's face. So it tries to show you like this is what we use in order to get to that result. And next. And what it does is more or less what is shown here. You have a real model that is really complex. And if you remember like early algebra, it's not early algebra, that's a lie. But like if you remember advanced algebra, you're gonna remember functions. And that you can have like a plus bx plus cx squared plus dx to the third. And LIME does not work that way. Like it will not be able to approximate every detail, but it comes from a premise that every machine learning model will behave locally in a linear fashion. So it will try to approximate the model, making a linear function iteratively. So it is a way to build a model exclusive to explain. It's the same idea of a secondary model, but it's built based on the actual one. It's more connected than just running a second decision tree, for instance. So this is one thing. And the other, yes, and the other one that is really common, is the one we use at Guppy, is SHAP. Next. SHAP stands for Shapley Additive Explanations, and it came from economics and game theory. So the idea was the Shapley numbers, they try to determine how much of a game, like suppose we're playing a game, and we want to know like a cooperative game, like I don't know, an MMO or something like that. And there is an actual prize, like a money prize in the end. And I want to see how much each person has collaborated to the final outcome. So Shapley started helping us calculate outputs that are proportional and that are equivalent to each person. So in the end, the attributions are fair. And this has a lot of applications for machine learning, because what we're doing with SHAP is essentially trying to understand how each feature collaborates to the final result. So how has each feature on average made that answer what it is, you know? So in order to make that more tangible, actually, can you go to the next slide, Andy, please? Okay, so this is what SHAP is. It is an average of the relationship between given a specific data point and its subsets. But I want to do that like in an easier way. So next slide. I'm going to try to show you how that works with the Expendables. I don't know if you've seen that movie. It's a fun movie. And I think it's good for us to understand more or less how SHAP works. So yeah, you can go ahead. So you start with a base or average value that the model predicts. So let's say that let's say that each one of these people, there are model features, right? Or there are players, and I want to calculate their contribution, their overall contribution. So what I'm doing is the model will predict, well, if I have those 12 guys together, the mission will be like $12 million, and each one of them will get 1 million. And this is the average value that each one of them collaborates for the group with 1 million. So we start with that. This is what the model predicts. But then later, next one, sorry. We have to start from scratch, and then we're going to see what we call like the marginal difference of a single person. So let's suppose next, I want to see how Statham does. Like if I get Statham, and I want to see how much he contributes to the overall result. If he's by himself, the model predicts that he would only make 500K instead of the at least 1 million he should be making, right? When he's by himself. But this is not enough, because he's not by himself. He's working with a lot of different people. So keep going, Eddie. So then I have to see like how Stallone does by himself, and then again, next, how Stallone and Statham do together. And I'm always putting like the number, like how much they would be making with that mission. And this would be something that the model will predict, the SHAP model will predict. Keep going. I have to iterate and keep iterating. Keep going. And making different combinations. And in the end, each one of these combinations will be averaged out, and I will have a final result, keep going, of how much Statham is worth overall and how much he should be receiving. Keep going. Keep going. Okay, so I'm going to do that for 2 n sets, because I always have to do it with a group with Statham and without Statham. And I'm going to repeat those subsets, and in the end, I'm going to have 2 n sets. So, and I'm going to find out that Statham's average contribution is 1.3 million, for instance. You know, and then I'm going to be able to explain, well, if Statham's not there, if it's not in the group, now like the output is going to be lower because he's not there. Or like if I have an apartment, which is the classical example for the SHAP, if I have an apartment that is worth 300K, like for me to buy, but the apartment accepts skets. So now I'll be able to buy it for $270,000, for instance. So I'm going to see how the cats, like the fact of that the people accept or don't accept cats, affect the overall price of the apartment. And this is how SHAP works. So yeah, keep going. If I want to compare LIME and SHAP, I have things that I have to take into consideration, right? So LIME has no averaging, it has no weighting. Like it's just linear approximation. So pretty much every feature has the same weight. And I do not consider subsets. I only consider the model as a whole. For SHAP, the features are weighted. So it's actually proportional, and I can use subsets to see the difference it makes, like by itself, and one more thing, and two more things, and three more people, and so on, until I contemplate the whole model. Next. So LIME cannot compare data points because it does not allow for subset comparison. It only compares, it only takes the whole global phenomena into consideration. And SHAP, it allows for specific comparisons. Next. LIME lacks formality, and SHAP is mathematically robust due to a lot of things like efficiency and additiveness and dummy variables. So it's really complicated to get into that right now, but SHAP is mathematically proven, and LIME is a premise. It tends to work, but it's not mathematically proven yet. Next. So LIME is able to provide an explanation using only some features of a model, and SHAP uses all features. And usually I'm saying this is a negative point of LIME, this is a positive point of SHAP. And in that case, if you're using some features of all features, to me, this is neutral because it depends on what you want to do. So it's not something positive or negative. Next. Because LIME is does not have to iterate for every single subset of features, LIME has a much lower cost than SHAP, which is really costly. Next. LIME allows for more clear interpretations because you would say, if this person has the flu because it's sneezing and it has a headache and it has no fatigue, for instance. In SHAP, you cannot do that. SHAP is usually numerical, and you have to say that on average, this is the impact that this feature causes on the whole model. So it's a much more subtle explanation. It provides explanations mathematically robust, but it's more complicated to convey to a user, for instance, or for a regulator. Next. LIME proposes a local model, and SHAP does not propose a model. It does not say, for instance, here, Stavum does not work that well with Jet Li, but it works really well with Chuck Norris and Stallone. So if they work together, this is better because they communicate better. SHAP will not do that. They will not propose a model. They would just say, this is the overall impact on average on this model. It does not say how that works. So if you put another feature with LIME, you can have an approximation or idea of how that would work. With SHAP, that's not possible. Next. And finally, LIME does not need the access to the original data because you can fabricate inputs and see how the outputs happen, where they fall. And for SHAP, you need access to the original data because you're not proposing a model. You're seeing the impact specifically. So yeah, next. So just to finalize, this is pretty much the end of the presentation. I'm not gonna demo anything here, but the problem with explainability that sometimes is very complex. It's something very complex to do, and it's usually very mathematically intensive. So Google has proposed a tool that is called the What If tool. And next, please. So the idea here is that you could inspect a machine learning model with minimal coding required. This is an actual tool you can use. It's open. It's on Jupyter Notebooks, on the Tensor board. So it has a lot of things that it allows you to do, even if you do not understand the mathematical intricacies. Next. So this is the overall screen and how that works. So you have essentially here, just to show you, you have the blue ones. This is a smile predictor, a smile classificator. And what the model is doing is trying to predict whether the person on the photo is smiling or not. That's pretty much what is used on cameras, right? If you detect a smile, you take the picture, or you wait for the smile to take the picture. So you have the blue instances, and they were predicted correctly. and the red instances that were predicted incorrectly. And you can visualize that, you can bin that data and see like how accurate, how sure the model was. But you can play with a lot of different things too. So I'm going to show you just like the resources that What If tool brings you. Next. So it allows you to compare models. You can plot two models side by side and see how they behave and how they perform. You can check like data points, different data points, and how each model predicted, and like use the ROC curves or confusion matrices, so you can decide which one is best for you. Next. You can also visualize distributions, just like we saw there. Like we binned the results from certainty to uncertainty and saw like what was correct, what was incorrect. You can also modify data points and see how that affects the overall result in the end, like if that is impactful. Next. You can analyze counterfactuals, which is like, is this one, like for instance, the one in that is squared with green, suppose it was correctly predicted, but is a really similar data point to that other red that was incorrectly predicted. And what you want to know is, what is the difference that made like two very similar data points be correct, one correct and the other incorrectly predicted? And what are the differences, and this is the closest data point you have with a different classification. And that allows you to understand better like what's going on with the model, because it's very visual, especially if you're dealing with images. It's something that sometimes you can like diagnose in person. Next. Okay, so you can plot ROC curves and confusion matrices. I had already said that, yeah. So something you can do, and then you can compare with different models. Next. And then you can also consider thresholds for fairness, which I think is really cool, because fairness is a very complicated subject, and it's very complicated to try and emulate that mathematically and consider that in the model. But you have different optimization strategies, considering like taking in consideration what you think is fair. Like, so suppose I believe in demographic parity. So for instance, if I have 70% of, let's say, applicants for a job opening, 70% of applicants are male and 30% are female. I can say that, well, in the end, if I'm hiring 10 people, 7 should be men and 3 should be women, because I'm directly connecting that with like the original applicants. So I'm respecting in the results the original proportion. But I can also, establish like women or social minorities, and I should help them out. So I can I can use a group threshold and be more optimized considering maximizing the number of women that get in the job opening. So there are different things I want to do. And it's good because you start thinking about what is necessary and what's like your positioning. You know, it's something you have to take into consideration in the models and for your life, really. So it's something that the What If tool helps you do. Next. Yeah, so as I said, it is available on TensorFlow. It is part of TensorBoard and is available in Jupyter Notebooks, therefore on Collaboratory too. Next. So yeah, this is just further reading because I'm gonna make the slides available later on, and these are all clickable. So you have all different papers you can read and books you can consult. Next. And like links for documentation and things that have really helped me understand Shapley values in LIME when I started studying that. So I think that's it. Next. Yeah. So yeah, thanks guys, and thanks for keeping up with the next. I hope you had fun. Thanks, Eddie.
That was awesome. That was really good. I thoroughly enjoyed that. That's why I kept on No, I didn't click next. It was Alexa. I think we've got this really good app where you just say next and it goes. And even sometimes it happened ahead of schedule. So that was really interesting. So thank you so much, everyone, for listening to the next. And I apologize, Bianca, for just not getting it right. I'm sweating. That's like really
No
hard
problem.
work, although I'm behind the scenes. But you did really well. That was like really interesting. And I'm sure we're going to have like loads of questions from people. So everyone watching, say thank you to Bianca, and also put your questions in the chat, and we will bring them up, and Bianca will answer them. So I'm looking forward
To
to
the best of my ability. Yeah.
some interesting questions. So I've used machine learning just as kind of at a hackathon, like throwing data at it and trying to train it, but not really knowing what's going on. So I think I used Azure, letting its magic just work. We got like, I don't know, 80% accuracy on images, and we were happy. But I didn't know what it was doing behind the scenes, so it explains a lot, because there were lots of options available, and I just left it on whatever it was set to when I opened
I
it.
see, like the default option. Yeah, but I think that's fine because this is a paradigm shift now that we're living. But usually people we weren't that concerned with knowing what was going on either, so you were fine.
And how long have you been doing this for?
It's not a long time really, like 2.5 years, I'd say. Yeah, I started on 2018. Like I was already. I'm not a data scientist. I do not consider myself a data scientist. I'm a product expert, right? Like I'm a machine learning expert, but I'm a product geek. So I work with data products and machine learning products since 2018.
I mean, I need to rewatch that again. There was so much good information that I was getting confused with the next and trying to watch it as well. But I will definitely rewatch it. It was really useful. I thoroughly enjoyed that, and
Cool, and
I'm
get in
glad
touch.
the
Yeah,
I'm glad the next didn't put you off as well. I will get that sorted for
no
next time.
work.
So, anyone, write questions in the chat. Let us know, how is your machine? Have you used machine learning before? Have you tried things? Did it work? Did it not? I mean, take advantage of Bianca, giving her time and her being an expert in this area. But maybe everyone's just trying to digest all the information that you gave them.
Yeah, it's a heavy talk. Yeah.
I really like the Expendables
But
one.
yeah, I figured that chap is so hard to understand. Like I'd had a lot of problems trying to explain it to my team because it's really hard to grasp like the concept. But everybody has watched Expendables and everybody likes Chuck Norris, right? So it's easier, I guess.
It's true. It was still quite hard though with numbers. Like it started off like, I don't know, making sense, and then slowly I got lost, and I think I found my way again, and then I got lost again, and so that's why I'm definitely gonna have to rewatch that.
Yeah, but like for you and whoever else is watching and like trying to digest the subject, like feel free to reach out like on Twitter or on LinkedIn and we can talk more about it.
Yeah, I will put your Twitter tag just below us now. So if anyone wants to reach out to Bianca on Twitter, do follow her, see what she's up to, and yes, send her a tweet if you have any questions. Bianca, thank you so much for your time. Is there anything else you'd like to end with?
No, just say thank you to you, Eddie, for like all the effort, and to Amanda and the GDG Cloud London for the opportunities. Just so nice to be able to give talks like across communities, especially now where we're all like quarantined, something to do and get our minds on. So thank you for having me.
No, thank you for joining. It's awesome. Like you said, this cross collaboration across communities is amazing. So everyone watching, don't go. We have Will coming on next very very soon. So he will be with us shortly. Bianca, thank you very much again, and I look forward to chatting with you soon.
Bye bye. Thanks,
Bye.
guys.
What an amazing talk by Bianca. That was like my mind blown. I'm so excited for the next one. Will, if you're watching, don't forget to join the link I sent you so I can pull you into the chat now. Sorry, not pull you into chat, pull you into the stream. It's only halfway and I'm really excited. So if you are watching, don't forget to give a thumbs up and subscribe if you want to get notified for future videos. And Will is here. Okay, let me bring him on. Will, thank you so much
Hey,
for
Ed.
joining.
Hey, thanks. Pleasure. Can you hear me?
I can hear you. Yeah, how you doing?
Good, good. So
Where are you?
far,
You in
we have
Brazil or in
coffee.
Australia?
Brazil at the moment. So yeah,
You're in
Salvador.
Brazil. Nice.
So,
Okay, I don't know if you saw the last, I think I saw you in the chat, so you probably saw the next per slide. So apologies, I will get this sorted for next time, but you're going to have to kind of give me a nod and a wink or say next if I miss it. And if I jump ahead too fast, if I get too excited, then do tell me to go back. And
no problem at all.
I will try and manage that. I'm sweating already. It's the stress of changing slides. It's really hard work. I don't want to like distract you. Okay, well, without further ado, actually, no, you need to intro yourself. Sorry, I'm getting too excited. Your talks are involving Angular. I got really excited. So please, Will, introduce yourself.
Oh yeah, my name is Wilson Mendes. I'm originally from a hometown called Salvador in Bahia. It's a state in Brazil. Work with web for more than 10 years, and currently I'm Google developer expert in web and web technologies and Angular. And today I'll be talking about something that's really cool, a hot topic right now, which is micro frontend, Angular, and how to make resilient applications.
Awesome. And just to add, I think I remember seeing in your description that you said, although you're using Angular as an example, you don't have, you're using Angular as an example, so it can be used with any library or framework. Is that correct?
Yeah, exactly. At the end, we'll be talking about few specifics about framework, but more generally, we'll be talking about techniques and architectural patterns. So it can be used in Angular, React, Vue.js, or any other framework or library they'll be using at the end.
Awesome. Well, I'm going to leave you to it. I'm going to get out the way and let me get your slides up as well. I should have done that while you were introducing yourself, so apologies. Let's get going. Okay. It's all yours.
So yeah, welcome everybody, and please get ready. Time to stretch, because right now we talk about micro frontends in Angular. And yeah, as I said, my name is Wilson Mendes. I'm a good developer expert web technology in Angular. But first things first, if we go to the next slide, you see that apart from Angular, in my free time, I do a bunch of crazy stuff. One of the stuff that I was doing is nodebots. Nodebots is just a combination of JavaScript and sensors, so hardware specifics. So if you want to play, or if you never played before, if you want to play, you want to see how can you productionize some code or some mechanism that we created, you can just go and download this book. There's a book that I published in a platform called LIME book. So the way to go is pretty much straightforward. You can go to that link, decrease the price to 0, and enjoy. So it's free, it's for the community, so just play with. And yeah, first, let's now start it. Next slide, if you go, is me. Yeah, this crazy person, it's me. Sometimes my mind look at that picture and say, what the heck are you doing? But yeah, this is not a real gun, by the way. I'm living in Australia. Australia doesn't have guns and allow it to have guns, and thanks God, it doesn't give you that permission. And but to align our expectations, let's talk for the first real truth, which is companies have legacy code in production. And that's a real truth. Sometimes an ugly truth, but that happens. And we need to deal with it. We need to handle with that every single day we're touching in the code base. And the next slide, we'll see that, for example, we have initial versions. Our application, when you look for an app that has more than 5 years, 10 years or so. Like currently I'm working in a company called Alazin. So if you ever heard about products like Trello, Confluence, Jira, Bitbucket, and so on and so forth, those applications that I'll be working right now. But as you folks know, those products has a really good relevance and also has a really good expertise on their code base. That means that it has some time, it was developed a few years ago, and we always have to think about it, how to improve it. But it can be any application at the end. For example, initial versions of those applications can be monolith, can be really high couplet code, yeah, and can have a different mix of layers. As example, when we talk about monolith, usually you have the same file can have pretty much everything that you need, and people can go nuts. So at the end, when you go and play with this code base, you see something like this. In the next slide, if you go further, yeah. And when you see this peak, the only thing that came to my mind is like, I know that you want to play, I know you're playing, but it's not the best way. So moving further, the next one, webpacks are evolving, and we need to be up to date with that. What that exactly means. In the next slide, we can see a really common picture for every app. We have the micro way, which is quite common right now. It came with the idea of break things in smaller pieces, like we have right now in micro frontend, and even before that, microservices, or even before that, let's split between domains. The whole idea of split stuff is how we can make things easier to upgrade, easy to remove, easy to push to production. At the end, all this complexity that we add in applications are based on give us the ability to move faster. So it can be microservices, micro frameworks, micro whatever. In this picture, you can see that we have different boxes and different layers. Those layers can be levels, those layers can be different pieces of application, a database, a specific front end, a specific backend, so on and so forth. So moving further, with all these ideas, we have micro front end, which now is hot as a really hot topic. But in the next slide, we see one really common question. What is micro front end? Is that a tool? Like, should I use, like I'm using React, like I'm using Node.js or something? Is that a framework? Let's say, if you look for micro frontend, you see that one of the really hot topics is, and really good searches is related to OpenTable. OpenTable, as other companies, they create a specific framework which help them to move forward in a micro frontend application. And with that, we have different companies like Spotify and Dancing and so on and so forth. But again, it's not really tool and framework, because the answer for that becomes right now in the next slide, which is a technique. It's a combination of good patterns and architectural patterns that you can use in your app. In the next slide, you see a really good point that how to solve architectural problems, because now we have that. The main combination with which became a name now called micro frontend is this. That's one of the keys. How to solve architectural problem. And more than this, if you go to next slide, there's one way to solve it. If we use evolution steps like we do, even without, it goes without saying, right? So let me give a good example. When the baby borns, he or she doesn't know how to walk at the first time. What it tries to move, it tries to talk, and starts to learn how to talk, learn how to speak, learns how to walk, one step at a time. And if you move this to our area and our roles, we can use this as evolutionary pattern, as evolutionary architecture. Like example, if you move to a different database, if you want to upgrade your application to a different framework or even a different version, those are the steps that you need to think about. Every steps matter, and all these steps will be crucial in your journey. And next slide. And another point that's always good to remind us is this is a good phrase that came from different people, and this one specific came from a person called Adi Osmani. First do it, then do it right, then do it better. That's the cycle that we need to keep in mind when we're doing applications. It doesn't matter if it's web, it doesn't matter if it's backend, front end, or any level that you're working. First do it, then do it right, then do it better. And next slide. This is a really common picture. Every time that we go to different apps, we can see one website can be like that, can be similar to, or yeah, it's a website. But moving to the next slide, you see that in this piece, we have three things happening at the same time. Those boxes with colors are related to each specific API calls that this website is doing. And in the green one, it gets information about the description or information about this website. And the yellow one is trying to get some pictures from the gallery for this specific post. Let's say that's a post. And the third one is trying to get specificities for that page. And it's breaking. So you have different levels of different API calls. That can be problematic in your app because in a monolith application, if you look for something like this, your app is broken because as soon as one is not solving, and it can potentially be broken because the whole page won't be loaded and will be rendered as expected. And next slide. And the code base is like this. There's no distinction of teams. There's no distinction about layers, which means that you in a single box try to deal with pretty much everything. Your code logic, your database, sometimes a cache layer, sometimes a front, sometimes a backend, and everything related to your app. It's hard to split between teams because at the end, you can change something in one page and break in another that you had no idea that could happen. And those are the challenges that we need to face, right? And next one. Now with the web, the web's evolving, and it's evolving so fast that we can, for example, create a componentization, and we can share components across pages and more than this across devices. As you can see in this picture, you can see boxes like yellow box, which is shared between mobile and desktop. And we still have those layers, but more than this. And if you move to the next slide, you see something curious that instead of split between API calls, you can split specifics about those components, and those components can be reused. We still have the problem though, because at the moment in this picture, we just split between components. So it's a small piece, it's a small elaboration sharing that you can share stuff, right? And next slide. Everything with this new web architecture, it's a component. So at the end, you have a component called page, which can be your home page, can be your dashboard, or any other relevant component name that can make some sense for you and your app. And this page is a combination, it's a composition of different components. Like we have here, component 1 is using component 2, component 2 is using component 3, and so on and so forth. The way you're doing is like a kind of Lego that you can combine in the best way for your app. And further, in the next slide, in Angular specific, you can use a concept that we call layout container. So you can split containers, which would be your page, or you can just split containers based on the different layouts between administration area and website area, as example. And it's really up to you. But the main concept here is like you can split that. Or for example, if you use React, you still can use this because at the end, you just creating a page container and giving a different name, right? So it doesn't matter at the end if you use Angular, if you're using React, Vue.js, or any other framework library that you want to. The main goal here is reuse and make your life easier. And next slide. So as soon as you split your app in pages, or at least start in the first one, the best way to start is like start, as I said before, baby steps, try to start for something, then try to dominate the whole world. Start with something, take the learnings, and share across the team or the teams. So in that case, now you have a single page with all what needs. It has a database, it has the code logic, can be the front end logic, can be the back end logic, can be a cache layer, it can be anything that's relevant for your app or relevant for that page. And it means more than that, that in case you need to scale up, let's say your homepage is have a huge amount of access at that moment, instead of scale the whole app, which in the monolith would be real true, instead of scale the whole application, you can scale the specific page, and you can have a lot of benefits of this, and it can decrease the costs as well. So yeah, moving further, everything is based on those pieces. First, you have components. Second, you have pages, and third, you have routing. Why routing? Because you need to validate that. I'll explain a little bit more about the routing specificities during this talk. But those are the things that you need to keep in mind: components, pages, and routings. Next slide. And keep in mind that everything is a component. You have a huge benefit on this. First one, you can split in boundaries. That means you can have scopes, really, really small scopes, and you can have benefits on this. And when we talk about components, we talk about plug and play. And when I talk about plug and play, I really like the next picture that we face. There you guys will see that this. I don't think too much about how I will use and how I should be using as far as I know the input and the output of that component. I'm good. So yeah, easy peasy, lemon squeezy, nothing to add more than this big. And yeah, and now that we have pages and we can split between pages, we can also create boundaries across teams. And scenarios like, hey, I changed something on the home page and I broke my dashboard page for some reason. That shouldn't happen anymore. And now what it is, you have teams, and those teams has ownership, full ownership of what they want to do and how they can move, and how they can roll the changes, how can you roll the improvements, and so on and so forth. And the impacts of this, they're quite huge actually. First one, you have ownership, as I said. Of modern days, you have flexibility. Let's say that you're using Node.js as a language for your app, but for that page, looks like Node.js is not the best option. Maybe you need to move for something else. It can be, I don't know, Elixir or any other language that makes sense for your app. You have this flexibility. So instead of try to do a big bang in the whole application, you can try to move that. And the routing will be good because you can move 10% of the users to this new stack and 90 to the old one, and try to manage that. So you can also use progressive rollouts to validate your hypothesis. Innovation. You can try to use some A/B tests on a specific page and don't need to overload the whole application. Things like that. Or even if you try to experiment something else, maybe a new library that you help you with dates or anything that comes in your mind and makes sense to that. And you are totally able to migrate your app page by page, which is quite amazing. And if you go to the next slide, all of these are possible because of this button. As I said before, the main goal is share few bits and pieces and few and how to move forward. This is a really good button that you can look. It's based in a tree, a native tree from Australia, which in ways to move forward and try to evolve, you start to kill every branch and create a new one. So as an analogy for micro whatever, for example, if you wanted to move to a huge and massive service to smaller services, you can use something like this. You can create smaller, really smaller microservices and start the migration one piece by piece and validate them. And the next, Now that we're talking about micro frontend, and we know that we can evolve every bit and piece of an app, can we use micro frontend in a PWA, in a progressive web app? Maybe even if you're using React or Angular or Ember or any other of those really cool frameworks and libraries that we have right now. And the answer is yes, you can. Uh, as example, the next slide you see an interesting pic. More than this, it's still the same website, but you can use something like this in your app. You can create a composition of different components and different frameworks and different libraries. In this pic, you have jQuery, you have React, and you have Angular in the same app. But why this is a problem? First, if you load all of this, that means that potentially you're not using this in any other place. So you're punishing your users by accessing your website, which is not good. And more than this, those apps, those frameworks, they are consuming memory in different ways, in different manners. They're not sharing anything at the first moment. You can make it they share, but it needs a little bit of work. So that means that if you're using a lot of memory in your app, you'll be really seeing this next picture. Those users will be seeing that. Oh snap. Unfortunately, for some applications, that something can happen. And this can be one reason. Memory leak can be one of the reasons. We have different ways to make it happen. And more than this, we need to keep tracking to make them not happen. We need to avoid them. That's one of the reasons why I don't encourage this approach. So yeah, concerns as well, because nothing's free. You need to think in bundle size. Every time they'll talk about micro frontend, people usually have examples trying to use different frameworks. So usually it became a thing as a migration pattern when you move to a monolith to a evergreen application. So keep that in mind, and more than this, keep that in mind that if you're moving for a new application, you don't need to have 3 or 4 frameworks to deal with. Bundle size one the point. More than this, if you have those 3 or 4 frameworks, this impacts the time to render your page, specifically time to first render, which is one of the most impactful metrics that you can track in your app. And because of this, you need to use different techniques to make your app faster. For example, prefetch, preload, those are the standards and patterns that docs like Rail can share with you. In the next slide, we have a really good talk that Sam Sakon shared with us at Chrome Dev Summit in 2017, and talking about the future of loading on web. It became for free when you use not only micro frontend applications, but web apps. As you folks can see in this picture, in this frame, you have different files with different names, a few files with JavaScript, a few files from CSS. When you do a different deployment, when you deploy a different page in a micro frontend application, it should be decoupled. That means that if you deploy a home page, means you're deploying only the specificities for that home page, not the whole app. And more than this, that means that if you have shared code, you still have cache. For the user at the end, the user will be loading only what it needs. In that case, the page2.js, it has huge win. So you can really optimize your cache layer, even the browser, or even if you use something else, a new technology like Service Worker or anything you want to, you can improve even more your cache layer and make it work for you. And the next slides, let's talk about the routing solution. When we talk about moving pages, how come we can use the old and the new app? You need to have this routing solution that can be Nginx or Akamai or any layer that you want to. And you start to say, think about this as a security guard asking where you want to go. If you want to go to this brand new world, you go to that way, you go to the left, otherwise you go to the right. And this routing will be checking with you for the users. Let's say 10% of my traffic will go to the new page. So I can check if this new page is really working as expected. And if so, I'll be increasing the rollout to 20% to 30%, 40, and so on and so forth, until I have the page fully migrated and I can kill the old stack. Right? And for the next one, specific about the routing, and we can go to the next slides and we can see, if you're talking about server-side routing, you can use toolings like Nginx and Akamai. It's really up to you, the best approach. I would suggest, if you don't have a team or if you don't have a really good knowledge on DevOps and infrastructure, move with Akamai or any other tool or platform that you can pay as a service and use this. And as soon as you build this knowledge, you can move for something else like Nginx or any other route that can really deploy and have full configuration of it. For client-side routing, you have this one called single SPA. So you can use this at the top level when the user is trying to manage the route, when the web app is trying to manage the route, and it loads to you. Let's say if you move from React to Angular, you have this client-side routing checking. Are you going to a page with React, a page with Angular, or should I move 10% of my traffic to this new page? What should I do? You can add this logic in this piece. It already has pretty much everything, but sometimes you have some logic, some domain logic that I need to track or you need to add. But that's a piece that I already have, so you can reuse it. And next slide. We have that, right? So let's think that in a migration, you're not having all those three, but you at least can potentially have two, right? In the next slide, we see how we can manage that. So let's stop talking about beauty and Unicodes, and let's see some real examples. You can use, for example, async port. So when you go to that page, thinking that we are using right now page components, you can import this new page and start to add the logic for your experimental feature or for your experimental page or for your brand new page. And also, another tip, always try to catch, in case you have errors, what's happening, so it can work in advance on those. And more than this, in the next slide, you can use something like feature toggle. This is an example of one library called feature toggle services. And straightforward for who don't know about feature toggle, is a way to enable and disable features. And using this library will give you this ability to enable and disable feature on the fly in your app. Account integration is really simple. If you go to the next slide, and with that, you have, let's say, we have a variable called async module and a function called is feature flag turned on. This is a feature flag that you can pass through, or you can use platforms like Launch Darkly, who gives you access, but it's pretty much an object with true or false. And if it's turned on, load the new page, otherwise load the old page. As soon as you turn on and turn off, this code will work without any change. So you don't need to redeploy, to do a new deployment to make it work. And demo or show me the code, I'll jump that. Unfortunately, I'll see them today, but I'll share the links with all this code and all this magic happening. But yeah, another point, monorepos. Monorepos is another hot topic and really can be a really good solution for your app. If you think that companies like Google and Microsoft, even Atlassian, are using more repos, it has a lot of benefits. Let's talk about some of them. The next slide, we see a few of that I think are the most important. But again, my personal experience, they're really well organized because you have everything related to your code base in a single piece. To make it faster, that means that you have a really proper tooling for it. So otherwise, you take more time than required, and you don't want to be in that place. So you have really, really proper toolings for different tasks that makes relevance for your app. So you have tasks, you have traceability, which is a really good part in talking about a code base, a really large code base. Another good point is that you can remove this layer of have to know about 15, 10 different repositories to make your work, and you can validate in a single repo. So you can work cross project, and you can manage all your dependencies in a single shot. Specifics about Angular, you can use Angular Workspace, can be a really good solution. The next slide will show the Angular CLI. It's a really good tool for Angular. It goes without saying, but if you're not using, please do. And I mean it, please do. Because it solves a problem that you can see the next picture. Instead of you think about all these tasks, because you have to, you need to think how can you manage the release, how can you prepare the release, code-wise, of course, but more than this. And what you want to publish and which distribution you want to publish. You want to publish ESM, ES5, CJS, and how can you run the test? How can you run the lint? How can you validate your code to see if this is working properly or not? Angular CLI is one of the tools that solves that for you. So it's a no-brainer task. But more than this, if you wanted to make it better, right now, one a good application and one a good thing that you can use is NX. NX, the Angular CLI pairs up, is a really good tool that you can use. It's Angular CLI based, and now it can run for different apps. Not Angular only, can run for React, can run for Vue, can run for Ember. So it's really up to you to use, and I strongly recommend you to use it. The way to run is really straightforward. It has proper docs as well, so you can just jump on their website and look at. But for example, for build, you can build only the affected code for your pull request. Let's say if you open a pull request, you apply some changes that affect 5 pages. You can build only those 5 pages. And if you want to run the unit tests or end-to-end tests, you can do the same approach. So that means that if you have a code base for, I don't know, thousands of files, thousands of lines of code, you don't need to run them all if you don't want to. For pull requests or small pieces that you really sure they are not changing anything else, you can do that. And NX does all the job of traceability and understand the impacts in all the packages for you. And this can potentially create new problems, right? Because we have a brand new world with really cool tools, but also became problematic sometimes. So let's do a quick recap, right? The next slide, we'll see that the main goal is all the code that we do, all the things that we are doing right now is to make our stuff easy to deploy. Something we need to keep in mind always. So it's good even for manage risks. In the next slide, you see another phrase which comes with the basics, which is release early, release often. If you work in a code base that every time someone says, I need to do a deployment, it's a kind of big deal, you need to work on that. You need to do this even more to make it something straightforward. And in the next slide, with all these toolings, with all this really good stuff that we can use Angular CLI, we can use NX, we can use monorepos in general, with all this tooling that we have available right now, we still can have broken code. That's a real picture. In the next picture, you see something like the Babel repository, right? Probably won't see even better. So let's see for the let's have a look at the next slide. So we have a zoom of the issue. That's the master of the project, and can be the master of your project. Babel uses a monorepo approach, and even with monorepos, you can have master broken. You can have code which is not the best one to go to production. How can you solve that? And for the next slide, one approach is a library called LandKit. LandKit is a library for aliasings. It's been used internally in our project and for open source projects like AliasKit that we have. And it's a way to create queues. So instead of you click the button and push to master, you push to LandKit lands your code and manage everything that needs to be managed. But let's see a real example. In the next slide, you see that we have 6 different pull requests, and they are all green, right? Master is still green, and they are all green now. And you have a queue using LandKit. That's a process that can happen, and that's the process that LandKit can solve, right? So you have 3, but now you have the number 1 because something happened in the middle. Maybe the pull request number 2 or number 5 broke something, and because of that, the number 1 it's breaking. And as soon as you push to master, master is broken. So you can have, perhaps you can have just a small regression issue or even something really bad. How can you solve that? If you go to the next slide, as soon as you use LandKit, if this pull request is broken, because before push to master, it runs all the tests that you have in your pipeline and you have in your monorepo. It doesn't matter the affected ones or not. It's a way for you to be 100% sure that that code is working as expected. And if it's not working, if it's breaking for some reason, it removes your pipeline and it won't push to master. So that's a massive change. But in the benefit of this, you won't have any regression issues or perhaps a production issue in your app. And in the next slide, we have another concern when you talk about how to make resilient applications and how to make micro frontend or any other person when you use that metrics. You always need to drive your solutions and drive your points based on the metric, based on data, right? Otherwise, it's just my thinking. The next slide, you see some dashboards showing different metrics. A garbage collector or memory usage can be something. Those are just to elaborate more about it, but can be something that really make you can be user conversion. Let's say if you work in e-commerce and for some reason after my change, because I changed the UI and I removed one of the buttons that you have, and because of this change, I decreased the user conversion. So users are not buying how they were buying before. How can I do? I can manage that, right? Or can be just simple as it is, like error reporting that increased or something like that, but have something. And the next slide, again, we have all this beauty, we have the routing solution, yada, yada, yada. But in the next slide, we have a really good question, which is, what if your API goes down? We are talking too much about the front end, but let's think how to be resilient across layers. And more than this, what if If you go to the next slide, another good question. What if your API have optional attributes? What does that exactly mean? More than this. Next slide. What if your types are not? Let me give you a real example of something that can happen. And the next slide, you see a payload, an API payload sharing some location information, which is fine, right? It's a JSON object with location, and this location has an array with some information. Really straightforward. But if you go to the next slide, you see that we have types for this endpoint response. So location is something that can eventually be there and will be array with something. Okay, good. And listing, it's another piece of this endpoint and can be pretty much anything. Can be a string, can be an object with a string, with a boolean, or with a number. So that means that if you go to the next slide and you see in your API this response and you're not expecting that, you can have a really ugly truth going in your face. Let's see the next picture. You'd see what I'm talking about. Yeah. If your code is not reliable enough to cover those things, or if you're not thinking too much and how can you manage that, you can have this scenario. And this scenario can be just the site's down in the best moment of the year and something really bad can happen. So things that you need to keep always in mind to avoid this scenario. So yeah, quick remind. If you go to the next slide, you have model reminder, Nginx recap. That can be React recap, Vue recap, but at the end, let's just remind us what we are talking about during this talk. First thing, think in architecture always, dependently of which one you want to use. Try to use the one that makes sense most for your app. Start with small steps and keep always in mind something called evolutionary architecture. Always think in a migration plan. How can you move forward? Because for sure you won't do a big bang. Please don't do that. And define routing solution. How can you serve client side? How can you serve server side? Do you want to use rollout, progressive rollout? So instead of push in a way that all or nothing, you can push to 10% of the users and keep improving this progress. And last but not least, monorepositories can help you out. They have proper toolings, they're really well made. Sure, use these in your benefit. Next slide. If you want to see more about it, you can just go to this address. I just wrote a small piece sharing how to do micro frontend with Angular, but in the README has another link sharing how to do this in React as well. I play with those two. I'm doing more examples with different frameworks and try to share different approaches, how to do this in a server side, in a client side, in a combination of both. So feel free to clone, fork, and play with. And yes, thank you so much for having me. I hope you folks enjoy as much as I am.
That was awesome to have you. I mean, what a full packed, talk. I think I need to rewatch the whole video of both of them. I mean, there were a couple of things that really stood out, but before I go into those, just say thank you again, and also people watching, don't forget to write your questions in the chat. If you have already, please write it again because I probably missed it trying to change slides and the stress. But Will was very subtle, and he was saying, as you will see on the next slide, but I need to sort that out. But I noticed that there was a big boo-boo that I wasn't expecting when your slide came up with demo. Oh my word, I was like, how are we going to do that? I wasn't prepared for a demo. So, but good save. Thank you very much, Will, for accommodating. I think that there are a couple of points that I really want to highlight, and I've forgotten one already, which is really stupid. But one of the first or second slide that said, I can't remember what it was. Like there was 3 steps. It was like try, like do it, and then do it good and then do it better or something to that effect. Do you remember what that was?
Oh yeah, that was one. A phrase for Eddie. Yeah, first do it, then keep doing it, then do it better.
Yes, I thought that was
There's more.
really good. When I saw that, I was like, I'm going to use that. I'm going to steal that. That's just brilliant, right? You can't do it better until you've done it already. So I think if people are thinking about doing things, just do it. And I really like those repos at the end of your presentation where you had an example for Angular, an example for React. And I will share these links. So Bianca's watching and I know Will's here. So both of you, if you just send me some links afterwards, I'll put it in a comment under the video and I'll pin it with all the links that you wanna share. So what questions do we have? We have lots of thanks. Let's see what questions we have for Will. Will, if you see any that you like that you wanna take, I'm just gonna put your Twitter handle back on the screen so people can follow you on socials as well. Definitely packed. In summary, it's about aspects fail-safe deployment, right? I'll let Will answer that. Let me bring that up on the screen.
Oh yeah, it's summary. It's Tibor, right? I'm not sure if it's Tibor or Tibor, so sorry if I'm misspelling your name. But yeah, it's as well, but not only. One of the main points, because at the end, our day-to-day basis work is related to make our life easier. And if your life easier means that make the web apps that we are working, or not only the web apps, but the apps that we're working better, that means that we need to deploy without any friction. So it doesn't matter if you work in the back end, if you're working in the back end and the front end or any layer that you're working, you need to make your life easier and you need to put stuff to production. So one of the main points is this, and during the talk, I was just elaborating more about how to make this in different levels and different pieces. Yeah.
I really like the examples. It was yeah, it was really good. Your videos though, when they came up and you were like next, I'm like I've pressed next, but it's taking ages to move across, and I pressed it twice once. I had to come back. Stress. I need to sort that out. But I think the audience really appreciate you taking the time and sharing your knowledge and experience. I think it was just yeah, I thought it was really interesting. Like so many gems in there. It was really packed. I mean, with the first talk, it's not my area of expertise, so it was all new for me. But with your talk, it is an area that I do, but still, it was all new for me. So I really enjoyed it, and yeah, I really appreciate it. Everyone says that this tool for calls is really fancy. Oh, I'm going to put that on the screen. Thank you very much. I really appreciate everyone's positive feedback for my guests, for GDG Cloud. Don't forget to follow the guests and GDG Cloud on socials, and don't forget to give the video a thumbs up and subscribe if you want to get notified for more videos. I don't think there are any more questions, Will, so is there anything else you'd like to add?
I just want to share with you folks, thanks so much for this initiative. I know that we're having some different times across the world, but first things first, stay at home. Second, stay at home. And third, let's be empathetic with each other. Thanks for having me,
Awesome.
folks.
Absolutely right. Will, thank you very much again, and I look forward to geeking out with you again in the future. Will,
Yeah,
be safe.
thank you.
I hope you really enjoyed tonight. I've thoroughly enjoyed it. Thank you all so much for taking the time to listen to these talks. I just had such a great time. I love seeing the chat going. It really inspires me, encourages me to hold more events like these. So let me know what sort of talks you would like to see. You leave a comment after the stream has finished in what talks you'd like to see. If you know anyone you'd like to see on my channel, I can reach out to them. Or if yourself would like to be on my channel and talk about a subject, even from a lightning talk, be something like 10 minutes to a 30-minute talk, that's also fine. So I do brown bags every lunchtime, 1 till 2 UK time. And at the moment, it's just a chill out session. Occasionally, like every few days, I have a guest come on and they'll share a lightning talk, or we'll just have a chat with them. But if you would like to see a lightning talk or give a lightning talk, let me know. I do have about 10 to 15 lightning talks lined up. So over the next couple of weeks, they'll come in and do 10, 15 minutes of a lightning talk, and they will share their experience and answer any questions that you have. Thank you all so much for joining. I really appreciate your support. Please keep it safe out there, and I'll be putting my details up so you can also follow me and follow me on Twitter, and yeah, keep in touch. I look forward to seeing you in our next live stream. A big shout out to GDG Cloud, because it's such an awesome community, and for Amanda for organizing this. Thank you so much, Amanda. I'm sorry I don't have a little kind of animated card thing for you, Amanda, to kind of put your details out. But if I move mine out of the way, they can find you via gdgcloud.com. So awesome. Oh, and on Instagram. Okay, I must remember, Amanda, next time we do a collaboration, we should actually get you on at the end or the beginning to kind of give a shout out to GG Cloud, but also I must have a card for you to have your socials. Thank you so much, everyone, for joining. It was awesome. I learned so much. Have a great evening or afternoon, wherever you are in the world, but enjoy the rest of your day. And I look forward to seeing you next time.